All right, welcome. Today we're doing something really cool. We're going to peek behind the curtain and go inside the code of an AI that's built to be a home loan officer. We're going to see how you take a really complex, real-world job and actually automate it. So let's jump right in. I mean, this is the big question, right? Getting a home loan is one of the biggest financial moves you'll ever make. It is packed with critical details, documents, deadlines. It really demands precision, and maybe most importantly, trust. So, could you really hand all of that over to a bot? Well, that's exactly what we're here to figure out. And we're not just talking theory today. Nope. We have the actual project files for an AI loan agent, and we're going to walk through how it's built, how it's tested, and, whether it's actually ready for prime time.
Okay, so first things first, the blueprint. Before you can write a single line of code, you have to really understand the problem you're trying to solve. And with something like a loan application, the problem, in one word, is complexity. It's not just one question, it's a whole chain of them, and every single detail has to be perfect.
Think about it for a second. Applying for a loan isn't just a simple question and answer. It's a very structured conversation. You have to collect a person's name, their salary, the loan amount, credit score, all this stuff. And crucially, all in the right order. If you drop one detail, the whole thing can just fall apart. So the AI has to nail this every single time with no exceptions.
So how do you even begin to tackle a problem that big? Well, the folks who built this system decided pretty early on that this was way too big a job for just one single monolithic AI. And the key insight here was to build a small team of AIs where each one has a very specific job. It's a really cool design pattern called multi-agent collaboration.
So, with that, let's actually meet the team. There are two main agents at the very heart of this whole operation, and they have very different but equally critical jobs to do.
As you can see here, we've got our two team members. First up is the home loan agent. The best way to think about this one is as the friendly front desk orchestrator. Its only job is to talk to you, the customer, and carefully collect all 9 pieces of information it needs. Then, you have the creditworthiness agent. This is the focused, heads-down, back-office specialist. This agent never, ever talks to the customer. Its one and only job is to take that final application and make the call, approve or reject. And this whole setup is just a brilliant example of a powerful design pattern called agent as a tool. See, the front desk agent, our orchestrator, it doesn't actually know how to approve a loan, but it knows an agent who does. So once it has all the info, it just bundles it up and calls the specialist agent, the same way a programmer would call a function or a tool. It's basically hiring the specialist to do one very specific task. It's super efficient.
So, how do you make absolutely sure that front desk agent follows the process perfectly every time? Well, you don't just give it a few suggestions. No, you give it a strict, non-negotiable rulebook. In the AI world, we call this prompt engineering.
Now, what's really fascinating here is the language used. This is a direct quote from the AI's instructions. Just look at how specific it is. A strict, state-driven conversation. And then, do not deviate. State-driven just means it has to follow a precise sequence of steps, or states. This isn't a friendly hint, it's a command. The developers are literally engineering the AI's behavior to be as predictable as humanly, or I guess, artificially, possible.
And here's that rulebook, broken down into 5 very clear states, or stages. The AI is programmed to only be in one of these states at any given time. It kicks things off in state 1, greeting you, asking for your name and salary, and it absolutely cannot and will not move on to state 2 until it gets that information. This state-driven design basically forces the conversation down a very predictable path, making sure no steps get missed, all the way down to state 5, where it finally calls its tools and gives you the final result.
Okay, so we've built the agent, we've given it a very strict rulebook, now it's time to actually put it to work. But how do we know if it's really following those rules? We kind of need a way to watch it think.
This is where this super important concept called observability comes into play. The whole idea is that you should never have a black box handling something this critical. So developers use a tool, in this project it's the ADK web interface, that basically acts like a mission control room. It gives you a live, step-by-step trace of the agent's brain, showing you the exact data it's looking at, the tools it decides to call, and the final response it puts together. It's all about making the invisible visible.
So the agent is built, the rules are set in stone, and we can watch it work. Now, for the most important part of all, the final exam. We need to prove that this thing is reliable, and the way we do that is with a really tough, automated evaluation.
And these are the exam questions. The evaluation process runs our AI through a bunch of different pre-scripted conversations.
You've got the happy path. That's a perfect standard application. You've got clear rejection scenarios, like someone with a really low credit score. And then you have the curveballs, the edge cases, like a user asking for a car loan, just to make sure the AI knows what not to do.
This really is the moment of truth. After all this careful design, all this engineering, did it actually work?
And the results are probably not what you're expecting. Out of the 4 big tests, 3 of them failed. Only 1 passed. Now, your first reaction might be to say, well, the project was a failure. But the real story is actually way more interesting than that.
So first, let's talk about what went right. The AI was graded on the quality of its conversation. Did it sound natural? Was it polite? Did it stay on topic? And here it passed with flying colors. It scored a 0.74, way above the 0.5 pass-fail line. So, bottom line, the AI knew how to talk like a loan officer. No problem there.
But here is the crucial part. It was also graded on whether it followed its instructions to the letter, specifically how it used its tools. And the requirement here was absolute perfection, a score of 1.0, nothing less. The agent scored a 0.8. Close but not perfect. And in a highly regulated world like finance, close just doesn't cut it. This is what caused those tests to fail.
So what does a 0.8 on following instructions even mean? Well, it means the AI understood the task, it collected all the right data, and it called the right tool. But the exact way it called that tool, well, that's where it got a little bit creative. Let's look at the actual log from the Happy Path test, the one that should have been a slam dunk. On the left, you can see the expected tool call, exactly how it was supposed to be. And on the right, what the AI actually did. See that? It provided all 9 arguments correctly, but it shuffled the order. Now, to a person, this looks like no big deal, who cares? But to a computer program that's expecting a very precise sequence of information, it's a failure. It's such a subtle error, but it's one that this automated exam caught instantly.
And that right there is why this isn't a story about a failed project. Not at all. It's actually a story about a successful process. See, the entire point of building these automated final exams is to catch these tiny, almost invisible mistakes before a system like this ever talks to a real customer or touches real money. Finding this bug wasn't a setback. Finding this bug was the whole point of the exercise.
So what's the big takeaway from all this? Building AI that we can actually trust, it isn't some kind of magic. It's just methodical engineering. It's about having strict rulebooks, giving them tough, automated exams, and having the discipline to find and fix even the smallest flaws. That is how a cool demo turns into a tool that you can actually rely on. And that leads us with one last big question to chew on. We just saw the final exam for a loan bot. But what about an AI that helps doctors diagnose a disease? Or an AI that helps manage our power grid? What kind of final exam should they have to pass before we hand over the keys to something that important? It's definitely something worth thinking about. Thanks for tuning in.